In 1969, Roger Penrose had an idea how an alien society could get energy from a rotating black hole by dropping an object inside the ergosphere, where it can have a negative energy. If the object splits into two and one part falls into the black hole, the other part can be retrieved with more energy than the original object, because it has lost negative energy. A minus of a minus makes a plus. In 1971, Yakov Zel'dovich adapted this idea and predicted that waves with angular momentum, known as twisted waves, reflected from a rotating metal cylinder, will be amplified. The cylinder sees these twisted waves to be rotationally Doppler shifted. That is, their frequency changes depending on the rotation speed. This is similar to the linear Doppler shift where the pitch of a police siren changes as it speeds past. If Zel'dovich's cylinder rotates fast enough, then something very odd happens. The Doppler shifted frequency becomes negative. These negative frequency waves just appear to us as normal positive frequency waves, but remarkably it changes the way the waves interact with the cylinder. The metal usually absorbs the waves, but when the Doppler frequency goes negative, the absorption becomes amplification, and the reflected wave has more energy than when it went in. Like with Penrose's aliens and the rotating black hole, the twisted waves have taken energy from the rotating absorbing cylinder. We found a way to prove this surprising and key piece of physics using sound waves. We used a ring of speakers to create a twisted sound wave and directed it towards a rotating sound absorber. We placed microphones behind the foam that also rotate to measure the Doppler shifted waves that pass through the disc as it spins. We can play back the sound recorded by the microphones as the rotation speed increases. What you heard is the frequency of the twisted wave being Doppler shifted to 0, where it becomes too low to hear. Then it gets louder again with increasing negative frequency, which as said earlier is just heard as normal sound. We can listen to this again, but now we plot the amplitude of the sound signal of the twisted wave. We can see that the sound is distinctly louder after the Doppler frequency has gone from positive to negative. We can compare this with sound through non-moving foam, where there is only absorption. We see that the amplitude of the negative frequency waves is much larger when the absorber is rotating. The area shaded in red is the region where the waves are taking energy from the absorber's rotational energy. This amazing amplification effect lies at the heart of Penrose's proposal to extract energy from black holes, and could guide new experiments towards amplification of electromagnetic waves and maybe even quantum fluctuations.